The learning goals for this video are the following. I can draw the line of best fit by hand for a linear trend, and then I can extrapolate or interpolate data, and lastly I can determine the equation for the line of best fit. So let's look at an example here. Olympic runner tracks how far they were able to run in the following times. 1. Draw the line of best fit. So I'm going to go ahead and graph this data. I'll pause the video and then we'll talk about how to draw that. So I've graphed the data. I put time, which is my independent variable, along the x-axis, and I put distance along the y-axis. So now we want to draw our line of best fit. So generally you want roughly the same number of points on either side of that line. So in this case we've got 4 points. So if we can have 2 on either side of that line, that would be ideal. The line does not have to touch the points, but if it does, there's nothing wrong with that. So what I'm going to do is I'm going to take a ruler and I'm going to try to get it so that I get roughly 2 on both sides. So let's see if I can do this. And I want to follow the general trend of the line here. Okay, here, so I've got roughly, this is on the line, this one's on the line, this might be slightly above and slightly below. So that looks like it's a decent line of best fit. So now the next question is, well, what's the equation for the line of best fit? So if your line runs through the y-axis, you can easily see where it runs through the y-axis. Then it might be a little bit easier to find the equation of best fit. But I'm going to assume that you're not sure what the y-axis, y-intercept is. So let's take 2 points on our line. So any 2 points that you want. So the 2 points that I'm going to take this point right here. Not the red point, but on the line. And its coordinates are, the x is 4 and the y is just above 4.8, so let's go with 4.9. And my other one I'll go with is, well, it happens to be a point and it's on the line, which is 2 and 2.5. So using these 2 coordinates, I can find an equation for that line. So this might be a review back from math in the past. So here are my 2 points. So to figure out the slope, which for an equation of the line, it's y equals mx plus b. This m is your slope. So to figure out that slope of my line, I do y2 minus y1 all over x2 minus x1. Really what this is saying is this is the rise over the run. So if you're able just to look at your graph and count the rise from here to here, and then the run from here to here, well, you can go ahead and do that. But assuming you don't, you can use this formula. So this is x1, y1, x2, y2. So slope, y2, 4.9 minus y1, 2.5. All over x2 is 4 minus x1 is 2. Do the calculations, 2.4 all over 2, which is 1.2. So my slope for this line, now I know my y value, or my m value, sorry, is 1.2. So now all we have to figure out is what is that b value, and we'll be able to figure out the equation of the line. Now looking at this, it looks like my b value, which is my y-intercept, when does it cross the y-axis? Looks like it's at 0. So if I wanted to go ahead and just write y is equal to 1.2 x, instead of plus 0, this, I can just leave it out, right? Plus 0 and just leaving it out is the same thing. Or what you could do is, if you didn't know off the graph you weren't able to read it, you take one of your points that you started with. So if, for example, I could take that point, and I plug in my values for y and x. So my value for y is 2.5, and my value for x is 2. And this should be able to tell you what your b value is. Now if we do this, you'll see, what do we get here? 2.4 plus b. Subtract 2.4 from both sides, and I'm left with 0.1 is equal to b. So pretty close to that 0 value that we were able to determine just by reading the graph. So my equation, the line, is therefore y is equal to 1.2x. If you read it off of the graph, you just leave it like that, or you can include plus 0.1 if you did the calculation. So that's my equation for the line of best fit. So we're done A and B. And the last question, it says extrapolate to determine how far the student would have walked after 12 minutes. So I want you to remember back about extrapolations. We're looking outside of our data set. So here's our data, and we only have information about between these two x values. If I want to figure out, well, what's my prediction for when it's 60 in this case for this graph, I need to extrapolate my data. So what I can do is I can use my equation for the line that I found and predict what the y value will be if I'm given a certain x value. So remember, our equation was y is equal to 1.2x plus 0.1. What does y represent? Well, y in this case is the distance. X is the time. So this y is the distance, and this x is the time. So if I want to know how far the student would have walked after 12 minutes, well, what is 12 minutes? That's my x value. I can only read up to 6 on this graph. So this is way, 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 way off the graph. It's way in this direction. It's when this value is 12. So if I want to find what my distance is, well, let's look at our equation. Y, which is distance, I want to figure out what the distance is when my time, or my x value, is 12. This is why an equation for your line of best fit is so useful. So you do the calculations, 12 by 12, 20. So 12 by 1.2 is 14.4 plus 0.1. So what does that give me? 14.5. And y is, remember, my y value is the distance, so this is measured in kilometers. So I was able, think back what we were able to do. We made a line of best fit. We created an equation for that line of best fit, and that helped us, that equation helped us extrapolate data for something that we couldn't see on the graph. We're making an approximation here. So ask yourself, were you able to draw the line of best fit? Do you feel like you can do that? Okay. Can you extrapolate or interpolate data? So we haven't talked about interpolate, but can you extrapolate data? And lastly, can you determine the equation for the line of best fit? So really you have to do this first, then you do the equation for your line, and lastly you can extrapolate the data.